Hey everyone, it's Mr. Canfield. Today we're going to look at the data and distribution review, which is the statistics unit that we do at the beginning of geometry, because that's where there's room for it. So I'm going to go through this whole packet as fast as I can, because I do not have a lot of time before my planning period is over. You don't need to know that. All right, list the above data in order from least to greatest. So in my class, you're going to be able to use Staplet on the test, so you could always pull Staplet in. You can pull Staplet in. Let me double check OBS, make sure that, yep, okay. So if I pull Staplet in, I can copy paste these numbers, and I understand that you have to actually type them since you can't copy paste off of your paper, but whatever. Remember, we're in the one quantitative variable single group, data paste, begin analysis. All right. So if I'm trying to list them from least to greatest, you know how to list them from least to greatest. You know how to make a box plot. You get your numbers here. Those are the numbers that go there. You know that you can change this to box plot, and it'll whip that up for you. So that's all done for you. Hooray, good for you. Create a histogram. Again, you have this so you can do it. If you want, though, you could do all this by hand, and that's great. And that's awesome and fun. Boom, there's my histogram. So lucky me, it's already there. And that's where these weird stretches came from. I put the histogram in here and took the picture of this and stretched it out to make it fit. All right, answer the following questions given the dot plot. All right. Is it possible to find the exact mean given this data set? If so, what is it? Explain in words. So yeah, it totally is. You can add them all up and divide by how many, and that would give you the mean. Oh, and then what is the mean? All right, let me get the mean. Let's see. So you could do it in here. You could type it in. It doesn't really matter. I'm just going to use Staplet because it takes care of the calculations for me. I've got 1, 2, 3, 4, I've got fives. So I've got 5 sixes, 1, 2, 3, 4, 5, and then 7, 4 of those. So I have the 1, 1, 2 twos, 2 fours, 4 fives, 5 sixes, 4 sevens. Begin analysis. I got the mean is 5.506. So I could write 0.56. I could write 0.56. I could write the whole thing. I could write 5. And just round it here if I want. If I was going to do that, well, the 0 gets told by the 5. The 5 says, hey, 0, round up. So 5.1. You could also say 5.0, and then the 5 gets told by the 6 to round up, so 5.06. I would accept any one of those answers. I would not accept 5. Mean needs to be more detailed than that. Explain if it's possible to find the exact minimum and maximum values for the data set. Let's see, minimum value, there it is. Maximum value, there it is. So it looks like the minimum is 1 and the maximum is 7. Hopefully me drawing that explained it if you didn't already know. Is it possible to find the exact median? If so, what is it? All right, so if you need any of this, you should write, you can pause the video if you need to, because I'm going to erase it all. Just want to erase everything. Oh, wow. Erase, 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 erase. All right, this is the main thing that I need to erase. Okay, so I'm trying to find median. I could use Staplet. The other way to do it is you cross out the lowest and the highest, then you cross out the next lowest and the next highest, the next lowest and the next highest, next lowest, 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 next. Okay, so I'm gonna end up crossing these two out at the same time. So that's between 5 and 6. That means our median is gonna be halfway between 5 and 6, which is 5.5. And if we go and look at my Staplet, that's exactly what my Staplet got for median. Is it possible to find the exact first quartile and third quartile? If so, what are they? So in my class, we did not do these together, but if you want to do that, it's you start at the median and you go towards the beginning, and you start at the median and you go towards the end. So it's the same kind of thing, but we have those here. So what measure of data from above would we not need in order to make a box plot? So to make a box plot, remember, we need the minimum, maximum, and the median, and Q1 and Q3. We need all of those. That's called the 5-number summary. We don't need the mean to make a box plot. So mean, which I don't know why I'm doing that, because I have the ability to type. Mean. All right. Oh, my wife's calling me. Hey, I'm back. Answer the following questions given the box plot. Here's the box plot. Is it possible to find the exact mean? Well, on box plots, we don't know the individual numbers, so no. Is it possible to find the exact min and max? Yep. There's the min, there's the max. So what is that, 24 and 34? What about the exact median? Yup. It's that one. So the median is 31. I didn't use words. You can use words if you need to, or if you want to. All right. Is it possible to find your exact first, third quartiles? Yup. Here's Q1 at 27, and here's Q3 at 33. All right. So IQR. A lot of my students are like, what's IQR? Every time I teach it. So I am begrudgingly going to remind you, IQR, you just take Q3 and Q1 and you subtract them. So I'll do 33 minus 27. $33 minus 27. I apologize for the juvenile handwriting. What is that, 6? All right. On the box plot below, label where the, all right, so median is right there. Q1 is right there. Q2, that's what that one is. I think we meant to say Q3 here. So let's edit that. Q3, so Q3 is there. The min is that one, and the max is that one. All right, tricky on the box plot below, labeled how the percentages are broken down. Well, in this one, we've got 25%. And then in this one, we've got 25%, and then 25%, and then 25%. Answer the following questions. That's every box plot ever. Each piece is 25%. How many total values are there in the data set represented in this histogram? All right, let's see. There's 1 here, 3 here, 7 here, 9 here, 12 here, 7 here, 3 here, 1 here. 1 plus 3 plus 7 plus 12 plus 9 plus 7. All right, let's see. What is this? 10, 11. Let's see. So that's 11, 11. So that's 22, 31, 45. Is it possible for the exact value 42 to be present in this data set? Well, 42 is right here. So yes, there's possibly something in the 42s, because from 40 to 50, there are stuff. There are things, there are numbers. But if we had said like 11 down here where there isn't anything, then that would have been a no. Is it possible to find the exact mean of this given data set? And to that we say no. It's not possible to find the exact, though we could approximate, because it looks symmetric. And it looks like our median is somewhere in this 55 to 70 range, somewhere in here. Minimum, maximum, actually no, it's not possible to find the exact min and max, because you don't know if your minimum is 20 or 21 or 22. You don't know if your max is 91 or 95 or 99. You don't know. So you can't find the exact mins and maxes. What about the exact median? No, you can't. Again, we can approximate that it's somewhere in here, but we can't know the exacts. That's not what histograms are for. So hopefully that makes sense, because I'm moving on. All right, we want to talk about skewed left, skewed right. Remember, we pay attention to where the tail is or where the outlier is. So where the little bits on the end are. So here's a little bit on the end. It is off to the left. So that means this is skewed left. That means that if we were looking at the mean and the median, the mean would be pulled left. So it'd be to the left of the median. And that is skewed left. This one, it's got some bumps on either side, but it's pretty much collected in the middle, and there's not a whole lot on either side. And it's kind of even. So we call that symmetric. And that means that your mean and median are going to be equal to each other or close to each other. So I'll use little squiggles and say that it's approximately the same as the median. And then on our last one, we have a tail that's way longer over on this side, and that's why we say this one is skewed right. And so in that case, the median would be in one place, and the mean would be off to the right of it. Let's see, this one, looks like we got another skewed right. We got the tail off to the right. So that's gonna be the same situation as this one. Skewed right, the mean is gonna be more than the median. This one looks symmetric. So we'll say right, we'll say symmetric. This one that's got a tail off to the left, so it's skewed left. Just draw the arrow, bozo. Left. All right, so hopefully that makes sense. We're in a couple more minutes. Should be just enough time to not finish this. I'll be back. All right, so you're given a survey to 130 students. Oh, I can't read. You have given a survey to 130 of your classmates, 62 boys and 68 girls. So I already know in my table here, I've got 62 boys and 68 girls. You've asked each of them whether they liked sports or did not like sports. 30 girls said they liked sports. So if I go to girls and liked sports, I can write 30. And 17 boys said they did not like sports. So to find the rest here, I could use 68 minus 30 to find that, which is 38. I'm going to do 62 minus 17, which is what, 45? So how many people liked sports? Well, there's 45 and 30, which is 75. 17 and 38, which is, let's see, 40, 55. So if I add these up, I get 130. I add those up, I get 130. Cool. So they should match. The totals should match. All right. Which boxes above specifically are examples of joint frequency? So the marginal frequencies are the ones that are off to the side. So these are marginal frequencies, and the ones in here are joint frequencies, where it's joining two different things, like liked sports and boys. That's what joint and marginal meant. Those are not, I wouldn't expect to see those words specifically on the test. More the ideas of what's happening in here is what matters. Now use percentages, fill out the table. So to find all these now, you're going to take each of these numbers. Let's see, we want the joint and marginal relative frequencies. All right, so like for this one, we're going to do 45 out of 130. This one will do 30 out of 130. So I don't know if you heard the bell rang, so I don't have time to finish right now. But I'll be back.